Yeah, hello everybody. Good afternoon and welcome to my talk, Migrating Kubernetes Workloads from Azure to CloudStack-based cloud. And a little bit about myself. I'm 43 years old, CEO and founder of SC Synergy. And yeah, I love open source for over 20 years, working with CloudStack for 5 years now. And yeah, when I'm not working on tech stuff, I like to do long distance motorbike rides. And yeah, it's something totally different. And it keeps the mind sharp. And yeah, this was this year on a really nice long 2 weeks ride across France. About SC Synergy, so we are a German-based cloud provider. We are in operation since 2005 and operating our infrastructure as a service cloud. And we also add some managed services on top to be enterprise, to serve enterprise customers at enterprise level. And yeah, we do that with personal and individual support so that what our customers like and enjoy, that they still can call. And that's probably one of the most different differentiators to, let's say, one of the big hyperscaler clouds, because there is nobody you can call. And yeah, we operate our stack out of 3 data centers in the Rhine-Main region. And yeah, we focus on IT security and performance. A little bit about our portfolio. So we have our cloud. So that's the main offering, but we also have some services around it. So we have identity and access management, and we have managed and DevOps services. And that's the key driver of that project, to get workloads out of Azure, because you need to have a lot of DevOps know-how to really move the workloads. And that's what we did in that project. So we used our cloud expertise and our DevOps engineers to make that project happen. A little bit to our infrastructure. So that's our cloud is spread. So we have 3 availability zones. So they're all pretty close, all in the Rhine-Main region. And so we can do all types of DR and high availability across multi-zones. So that also is required for moving customers away from hyperscalers, because that's what they are used to. So they're used to have multiple zones, disaster recovery options, and high availability. Yeah, so now let's dive into the project. So at first, a little bit of the project background. So I cannot name the customer because that's quite confidential. It has to do something with finance data, so it's critical data and a critical workload. And so the idea was to migrate 4 Kubernetes clusters out of Azure. So there's like a traditional setup of development, staging, production, and the tooling cluster. So they all need to be moved. There are around 110 persistent volumes, around 10 terabyte of data on block volumes, and 3.5 petabyte of unstructured application data stored in Azure Blob at start of the project. Then there's the networking. So they have VPCs and site-to-site VPN tunnels to some customers to have access to application data. So that's also something that needs to be migrated. And it's a tricky part because it's networking, it's IPsec. It involves also the customer endpoints. So quite a tricky thing to do, needs a lot of planning. And then there are, of course, all the CI/CD pipeline stuff that they build the application with. So one thing to know, when we started the project, we started in August with that migration. The start of the project of the customer was already 10 years. So there is like a 10-year-old project. So it's not something that's built up completely new. So and that's not made it easy. And then, yeah, they brought also a lot of stuff like they use Terraform. They have traditional makefiles, and they use Travis CI for their automation and build pipelines. So they already brought a lot of tooling. And another thing to know is, and we found that out along the project, that the project was initially started in AWS. So they already had one migration. So they already migrated from AWS to Azure and now to CloudStack. And the funny thing is, there's still some services left in AWS. So we found that on the way. So the DNS service is still in AWS because there was no really Azure replacement. But now we also found a solution to take DNS out of AWS. Yeah, and then for sure what they also do, or what developers like to do, use native services. Not only that already Azure Blob is something native, they use Azure Document Intelligence services and the bot service. So that's another hard part of that process, because that's something that's really tied in to the application. And that's still on our to-do list. So that's not done yet, but we have an approach for this, because now with CloudStack 4.21, we can make use of GPUs, so we can spin up our own LLM and create some models to do document recognition. So there are already stuff out there, so we can make use of GPUs inside CloudStack, build some LLM on top of that, and do the document recognition, and also a bot service. So that's also then possible, but still needs to be done. So what was the motivation for the business motivation for the customer? So one thing is cost. I think we heard a lot about cost savings, and even more important, prediction. So the customer wants to be sure that he knows what he's paying in the next couple of months and in the next years. So we can, with our pricing model, give him a stable pricing, and not just increase like Microsoft is doing it. The next part, it's sovereignty. So that's also something even more important actually than the cost, because like I said, it's a customer out of the finance sector, so they really need to know where their data are at, and that they're really protected. And then for sure they want to reduce the dependency on the proprietary cloud services like Azure Forms, blobs. That all makes it hard to move. What he now found out, it's really a hard process, but it's doable. And yeah, then for sure increased operational transparency and control, because now he can look inside, together with us, inside the complete stack, so we know on each and every layer what's going on, and have the full control and full access on everything. Yeah, and he also wants to reduce existing tooling. So because being in AWS and Azure with all these tools, you spend also a lot of money on tooling and additional services, and also bring that down was one of the motivators to that project. And for sure, long-term flexibility through open source, that's and open standards. That's also something really important, and being motivating that project. Now a little bit high level overview of the migration architecture or the workflow. So what we did. So at the first we did an assessment and an inventory. So that took already, with that complexity, a couple of days to just understand what they did and to come up with like an idea how much effort it would be to do the migration. Then the next step is infrastructure provisioning. So we need to prepare the infrastructure for deploying the workloads. And then we started with the dev and staging cluster migration. So that was the first step to bring over dev and staging cluster. And then the next tricky part is storage and data transfer. So we needed to come up with an idea how to migrate these 10 terabyte of volume from Azure to our cloud, and not doing it too many times, because transferring data out of Azure generates costs. So, we cannot do it 10 or 20 times. So we basically set up a synchronization with rsync and move the data over that way. And with that proven, so that dev and staging was moved and running, data was synced and transferred, and then we went into the production cutover, and so cut over the workloads, and did the VPN migrations after that. So there was for sure loss of connection on the VPNs for a couple of hours, but that was okay. And then the last step is cleaning up all the Azure environment, decommissioning everything that was on there, and getting rid of the tenant over there. So that's how we did it. And key challenges. So that's really there was really a lot of thoughts going in, because for sure we had to refactor part of the applications. So we had to make use of native S3, get rid of Azure Plop and all the Azure SDK stuff. Then the Terraform needed to be completely transferred to make it compatible with CloudStack. So that was another challenging task. Then for sure the networking is quite different. So migrating everything to VPC with the load balancer, getting all the routing set up, but it's done. And what we are still working on is replacing these Azure native platform as a service offerings. So that's still ongoing. And another challenge is the risk of downtime during data migration. So when you migrate data, always something can go wrong. So that was a risk. And one of the most important topics is training and change management for the team on the customer side, because now they lose their comfort zone that they're in with Azure, because everything is quite simple. You just drop in the SDK to .NET and you can just use the service. Now you need to do some more work, definitely. And maybe it's not so smooth in all stages, but at the end, you end up with something that you completely understand, that's yours, and you can move, if you like, to any other cloud without doing all of that work again. Then the CI/CD and infrastructure automation. So we try to reuse all the make files, but there was really a lot of work in it was like more than half of a rewrite, actually. And this mostly because of the already 10-year-old stuff. So they used a lot of packages that are not available anymore at an updated version. So we had to do a lot of update stuff. So the application consists of over 40 microservices. So you get an idea how much packages are involved when you have an application with around 40 microservices running. and reuse the Travis CI pipeline, get that up and running, and the goal was try to preserve as much as possible from the existing workflows. And at the end, it worked out, and lessons learned from that is abstract cloud-specific configuration early in your project. So even if you start something on AWS or Azure, don't use all of their native services. Try to keep it to standard. Makes it much easier if you decide to move. Pilot migrations, it's important to do. Definitely reduces risk on the project. Networking and storage, it's definitely the most complex part and needs validation before you do anything. That's really, you need to be sure that part is 100% working. And then, all the hidden stuff that comes along. So that's was definitely a challenge, like finding DNS on AWS. So, some key services also left there. Kind of interesting. But we managed it. And then do blue-green or parallel cluster enable to do it safe migration, to have a safe migration path. And for sure, during that time, there will be a little bit of double cost because it's still running on the old infrastructure, but the customer has already to pay for the new one. But it's definitely worth it at the end. The result, we did it, so it's successful migrated. And now the customer has a lower and more predictable operational costs, so that what we already achieved, the application is running. It's updated, so that's also something he gained. And part of it are then on actual versions. And he has full ownership and visibility of the infrastructure. He can look into everything. So what we have left is some monitoring stuff. So what we already did is backup for sure. So we use Velero backup to back up the Kubernetes stuff. But we still working on some monitoring stuff and to move the Azure document services over. Now he is improved, it's flexible, and hopefully he will be a long-term customer and can scale on our infrastructure to the level he needs. And now he's in a neutral and open source friendly ecosystem, so that's what we achieved. Conclusion is, it's possible. So it's possible to move workloads from a hyperscaler to Apache CloudStack. The only thing you need to get started on it, so that's most important. And you need some smart people to figure out all the small parts that block you on the way. And then you make it a successful project, and you can have technical and also business benefits on it.